Welcome to Inside the Castle, the podcast that goes behind castle doors to have real conversations with real people about solving the nation's toughest challenges.
I'm one of your hosts today, Aaron Schneider.
And I'm Angie Fryermuth.
In this episode, we have a very exciting topic. We are talking about artificial intelligence. And with us today is Evan Smits, who's an architect manager for data and AI with Microsoft. Evan, thanks for joining us here today.
Thanks, Aaron. Thanks, Angie.
So, Evan, before we jump into talking about AI and what that means for us and the future of the Corps of Engineers, could you tell us a little bit about yourself and your background?
Yeah, the short version, as you mentioned, I'm currently an architect manager in our DoD services organization within Microsoft. I've been at Microsoft for 16 years now. I've had roughly a 30-year career, and that has spanned kind of quite a few different roles between sales and also technical delivery, but probably predominantly in the technical space throughout my 30 years. The first 10 years was focused in commercial, primarily in the financial services sector. And then starting in 2003, I started working with Department of Defense customers and have been ever since, the last 16 of it with Microsoft. I spent time as a consultant for a little over 8 years, a couple of years in a sales support role, and then I've been an architect manager for solution architects, building out solutions for data and AI for coming up on 6 years now.
So thanks for joining us. And artificial intelligence seems to be a hot topic in the workplace these days. However, I'm not sure people truly understand what AI is and how it is beneficial to an organization. It seems like it's just a hot topic and everybody wants to do it. So just to help set our audience straight and have like a general sense and a baseline of what it is, can you tell us what artificial intelligence is and, what it maybe isn't?
Well, broadly speaking, the thought process around this goes back as far as, 60, 70 years around with the advent of digital computing is where could we potentially take digital computing to the point where it could, potentially even replicate or exceed human cognitive abilities. So that's like really broadly speaking and very much in the kind of iRobot, Isaac Asimov, philosophical terms, right? But then within artificial intelligence, you're going to break it down into different disciplines. And as you narrow the shot group down into like more specific meanings, you're going to come across a whole bunch of different topics, right? One that's going to feature very prominently is machine learning. And there's a variety of different kinds of machine learning. Those include, types of classification or regressive modeling. It's easy to get lost in the sauce, as it were. And one of the big challenges, I think, for everyone, right, to understand what is AI? How does it have, what implications does it have for the workplace? What can it do? What can it do well? What can it not do well? And so on, is trying to get around some of the underlying complexities. Because as you move from machine learning, you can move into deep learning. And then there's been so much discussion, especially in the last year or two, because of the advent of generative AI. And that is AI models that are trained on so much content, so much text, so much produced human language that what you're really creating is a model that can actually generate speech, right? To basically interact with all of us as a human would, with a data set of what it knows of existing quote unquote knowledge, right? But then to move beyond that in terms of if I provide it a new subset of knowledge for it to actually very quickly incorporate that and then summarize that and respond it back to me when queried with a particular question. So there's a number of different components that stretch from AI as an umbrella, then moving down to machine learning, then moving into knowledge mining or deep learning. And then within that, you have things around like natural language processing, and then moving into generative AI is kind of like at the kernel. And that's the most recent thing that's caused all of the significant excitement, I think, is people are starting to have now opportunities and it's out to the masses, not confined to like academic research groups or those places where these things are being invented, but we're seeing the mass audiences across the globe now having the opportunity to interact with various types of generative AI, not just text, but also with creating imagery, creating music, and all those sorts of things. So that's you created this kind of nexus point for us to ask all these questions. Well, where did this come from? What can it do? What can it do well? What does it not do well? How does it impact me? How does it impact me personally, professionally, and those sorts of kind of avenues of exploration and discovery.
So when you talk generative AI for our listeners, does that mean something like ChatGPT? Is that generative AI, or what do you mean with that?
Yeah, ChatGPT is just one implementation of generative AI. And so that is, by and large, folks who interact with ChatGPT, and there's several different versions, right? We had for Azure OpenAI, the first release that was available through, and most folks with Microsoft, they're familiar. They can go out to bing.com and click on the Copilot and start asking questions. That was initially AOAI was released with, that's Azure OpenAI was released with ChatGPT 3.5 Turbo. We're now on ChatGPT 4. So those go through different iterations, and that has a reference to basically how much content has this been trained on, what set of events or maybe world facts is it up to in terms of how current it is. But there are many other models that are out there. I think Facebook has Llama, which is an open source model. There's other for-pay models. And obviously those models can be very prescriptive relative to being targeted at very particular applications. On the image creation side of things, Microsoft has DALL-E. So DALL-E is out there for, hey, I want to go and create a logo for my softball team, right? And incorporating these kinds of ideas and these kinds of colors, and DALL-E can create an image for you. That is maybe at least a starting point. But then there's many other models that might be focused on healthcare, that might be focused obviously on autonomous vehicles. Think, for example, like a Tesla, or most of the major automotive manufacturers have some type of either self-driving or assisted driving that's all driven by AI. So those are very targeted towards that problem set, right? So the AI that gets your GMC Tahoe to stay between the lines, even when you're towing a camper, is very different than maybe an AI model that's going to come up with how do we address, say, post-operative or perioperative care in an oncology unit in a hospital, right? So generally speaking, if we take something like ChatGPT, that would be more of a generalized generative AI model. Think of that in terms of trying to address the broad masses relative to the most number of questions about the most number of topics, but not necessarily deep expertise in a particular area.
That's really interesting. And it's fun that you mentioned the logo development. Actually, the team building exercise a couple of weeks ago, our team went in. We all tried to develop logos, and it was a very fun experience to try to do that. So it's fun to be able to play around with this AI. It's interesting that you talked about how some are specialized AI, and I guess that's similar to how the workforce is. You have some people that are specialized in things, but for the most part, all of us are able to drive, and all of us are able to do other things. So I don't know if we're more generalists by nature, but we all have those specialties. How do you train AI to be either the generalist or the specialist? And how do you see that working, or can you explain that to our listeners?
It's all based on the data that you feed into the model, right? So there are going to be limitations in compute, and they're also, the wider your content base is, you have to think about, like, for example, if I gave an AI model all information known to humankind since recorded human history, there's not necessarily agreement, right, on what the answer would be. Right. For example, I used the medical example of, like, say, perioperative or postoperative care in a healthcare setting. Are we going to introduce, bloodletting from the 17th century or the Middle Ages, right, into as possible answers for what should I do about this fever that I'm feeling, right? So the data basically that you use, the content that you use to train the model, is going to determine its specialization versus generalization. And it's also going to introduce that design trade-off, right? So, like with any type of engineering, there's a design trade-off, right? With whether we're and I'm relating this back because of specifically Army Corps of Engineers. If you take a look at, say, some of the operative capabilities that the Corps does around let's say managing, our hydrology systems. I know with my brief interactions with some of our account teams, I was stunned to learn, I think this was a few years ago, how many hectares or millions of cubic meters of water that are under the responsibility of the Army Corps of Engineers. And so the predictive models, and I'm going to run into a specific Corps of Engineers problem. What is managing the watershed in, let's say, the Mississippi River system? How does that compare to, say, California? What does absorption look like? What does runoff look like? A model, you could come up with a general hydrology model, AI model that's specialized for hydrology and managing watersheds. And that's going to be important and purposeful for the Corps. However, you're going to want to start driving retraining of the model around specificity, because I think if you look at ecosystems, what is the runoff? What is the absorption rate in, say, California or Colorado as compared to, say, Louisiana, or compared to, say, Puerto Rico? Or are we talking about eastern Puerto Rico, where El Yunque is, and we have a tropical rainforest, the only national forest that's a tropical rainforest? Or are we talking about the western part of the island, which is much more arid, which would be akin to, say, Colorado or northern New Mexico? So that's where you're going to make design trade-offs, and it would be really important to start tailoring your model to the intended purpose.
Thank you for that. So let's talk a little bit about how do we know what analytic tool to use and when, because it seems like there's a whole suite of tools out there to use, and it's important to understand, just like you said, what one to use to make sure that we get the correct output.
So, Angela, that's a really good question. I think that there's some general themes and general principles that apply, and many of these things that I'm going to describe aren't specific to Microsoft, right? They're independent of technology. In fact, they come from third-party research groups and research that we incorporate relative to how we address the industry and how we address what products and services we can try and bring to our customers. So, for example, Gartner for many years used a maturity model. And if you talk about different types of analytics, and there's generally speaking 4 that are pretty typical. I know they come out of the Gartner model. I don't know that Gartner pioneered these or if other, research groups were involved, but you basically talk about descriptive, diagnostic, predictive, and prescriptive, right? As 4 kind of stages. Now, that works in the context of maturity. And when we talk about, those are fancy terms, but descriptive relates to what happened. Diagnostic starts to get into why does it happen? What are the relationships or patterns between different parts of my data? What is the relationship between the color of my couch, the thickness of the cushions, and how comfortable it is to sit in? Maybe I can learn that color is irrelevant, but thickness of cushions is very irrelevant. That would be diagnostic. Then I move into predictive, where I can start to say, hey, I've looked at 1 million couches and I've done all sorts of analyses relative to the size and shape and thickness of the cushions. And therefore, I can make some prediction if I give it a new couch and it looks at those features, that it can then label it or classify it, or even from a regressive machine learning standpoint, predict it's likely to be 80% comfortable or 90% comfortable, right? And then prescriptive, and that's considered the most mature stage, is that I've got my diagnostic patterns understood, the whys, the relationships between data sets, data fields, data labels, data features, and I've got large data sets across different disciplines well understood, and I've created machine learning predictive models or classification models, right, to either predict a value, like how likely something is to happen, which is on the regressive side of things, or on the classification, like it's comfortable or it's not comfortable. Then I can get to the point where I can do recommended actions. Like an example would be, think again, I'm going to go back to a hydrology example with the Corps of Engineers, is if I had a whole bunch of IoT sensors all across a watershed and I'm tracking rainfall and I have all these well understood things around runoff, absorption rates, buildup, and so on. When you get to prescriptive, that might be the point at which it would recommend to a dam operator that an adjustment to an outlet valve to basically increase the outlet at a certain time. And to decrease it at a certain time relative to what is that increase going to create in terms of downstream impact to ecosystem and so on and so forth. So this basically builds up to the point at which And again, there on the far end of prescriptive, it would be empowering AI to take action, where it actually makes those choices and makes those decisions and is starting to control actions in order to either promote the positive or prevent the negative, or minimize the negative, right? Or ameliorate or mitigate. Because again, even in those circumstances, and you can take, and I think this relates, the Corps has extensive experience, I know, related to hydrology. You take, for example, there was a resident hurricane that spent several days over Houston, right? You have to make some really tough trade-offs of like, you're trying to make choices between, do I do $6 billion of damage or $2 billion of damage? What is the human cost? How many potential lives are at risk? And how do lives at risk in the Houston area during that event relate back against infrastructure damage? So those then even start to spread into ethical concerns that are impacted by your design trade-offs. That's how, this can eventually lead from, initially you start with straight dashboards. How many sensors do I have? How much rain is falling? How deep is the water in my reservoir? Goes to the relationships between all those things, goes to it trying to help me tell what's going to happen tomorrow or the next day or the next day with respect to a hurricane or tropical storm, to then, potentially either recommending or actually taking actions. And taking actions, I'm again going to start having design trade-offs.
Yeah, I think that's really exciting and interesting, and I could see it from a strategic leadership perspective. Being able to be informed for those trade-offs, and a lot of times as decision makers are always making trade-offs. Looking at the strategic decisions and how it can help inform those, like you talked about a little bit. Could you talk a little bit about the difference between business intelligence and artificial intelligence? I've heard both of those terms. I'm not exactly sure what the difference is.
Business intelligence, and if you actually reference the Gardner maturity model, they split it right in half. So that the descriptive and diagnostic, where I say what happened and why did it happen, that's all on the traditional business intelligence. What would be covered under, generally speaking, modern data warehousing. But then when you move towards invoking machine learning, invoking predictive analytics and prescriptive analytics, actually leveraging artificial intelligence, that's where you move over to the AI side of the house. So BI stays with, business intelligence stays with descriptive and diagnostic. Artificial intelligence is now I'm leveraging statistics, analytics that are predictive and prescriptive in nature. And there's a long catalog of various capabilities on that AI side of the fence. So it could be predictive maintenance, it could be predicting how much rainfall will impact a reservoir in a particular watershed, but it could also be things around natural language processing, which is I invoke speech to text, right? So I'm talking and, teams might do a transcription of that, but then how do I then do a synopsis of everything we talked about today? That's built into a version of Teams that I have at Microsoft that is forthcoming and available, to different customers. You're going to string together a variety of different targeted AI capabilities that when you glue those together, they become a solution. And I think I always use the metaphor of baking a cake. So if you watch the Great British Baking Show, and I'm a fan, is that, there may be different cakes that have more flour or less flour, or more eggs or no eggs, or more sugar or no sugar, or maybe I'm doing a gluten-free recipe with, some other non-wheat based flour, right? So the same thing applies in terms of choosing the ingredients that line up together. They make an end-to-end solution around addressing a particular problem set. So you would go back, that has to be driven for the Army Corps of Engineers, that would be driven by your various mission sets. I talked about hydrology already, but I also know from other interactions with the Corps, again, the average American would be stunned, but it's in your mission set to manage an incredible number of facilities across the United States, federal facilities, campuses, buildings, and so on and so forth. And that includes physical security, it includes all of the public works, is the water working to the building? Is the electricity working to the building? Sewage, HVAC. So there's a lot that goes into it. One solution for hydrology is different from the chain of solution that might be appropriate for, let's say, permitting and environmental impacts relative to, some large infrastructure thing like putting in a new interstate highway in some location, right? Which would be, again, perhaps another part of the core that would be engaged.
So how much data or information does a bot, or I guess that's what you would call it, need to know in order to make a good product? And how does it learn? Right? So, there's tons of information out there. Are we teaching it as we're talking through devices like our Alexa or like Googling something? Just curious on how that all works together.
Wow. We could set aside like a couple semesters at a university to just answer those questions. Is the question first about data, and then how does it learn? Is it learning from us? And those answers are going to vary. So generally speaking, you're going to say the more data, the better. However, even with AI, garbage in, garbage out applies. So the AI doesn't necessarily know on its own. Machine learning doesn't know on its own unless there's some mechanism of doing validation, whether the data is good or not. So some things around master data management and data quality services still apply. So there's these great principles of data quality that were introduced way before AI became kind of an active discussion in our lives over the last 2 years. And that related to modern data warehousing around making sure that my data is accurate, that it's complete, that it's up to date. Those same principles apply in terms of if you're training, whether it's a targeted, let's say, regression algorithm, machine learning model, or whether you're training a generative AI model on large bodies of content, the more current, accurate, up-to-date information that it has, it's going to improve the outcome. So there's obviously design trade-offs, and there's also going to be performance trade-offs, right? So it'll give you a vague and ambiguous answer if you give it enough data that there's conflicting opinions. You can do this right now if you go to Copilot and you ask it anything that's contentional, like ask it a question about politics, ask it a question about religion, and you're going to get an answer where it's going to say, well, some folks say this, but however, other folks disagree and say that. You can go ask it a question, well, will AI, get rid of the workforce? And you're probably going to get multiple answers. It's going to say, here's 3 different perspectives, because there's 3 different perspectives contained in the underlying data. Now, that's more problematic when you're trying to ask a question of, at what time do we need to open the outlet valve for a dam on a reservoir by how much in order to ensure that we don't engage the spillway? You need to make sure that you have enough data to answer the question accurately. So that's maybe a verbose way, Angela, of asking your question in a way to say, you want enough good data that you get a good answer. So maybe I might perhaps that's me cheating a little bit, but that kind of addresses like how much data do you need, what kind of data do you need, and how does it learn? Is it learning based off of us having the conversation? The answer there is it depends. And there's an ethical consideration there, right? So one of the serious concerns that folks should have is around every AI-enabled kind of device or app and so on that you work with. You need to understand what are the terms of use. A couple years ago, they had a thing on Facebook, I think, and one of my family members said, hey, look, cool, I can upload my photo and it'll show me what I look like when I'm 80. I was horrified. And I said, well, look at their terms of use. You now gave them ownership of that photo in perpetuity for all of the rest of duration. Now, that's not a harp on Facebook, right? I'm not calling them out. I'm saying that you do need to consider what happens if you're voluntarily contributing data. Like that's come up quite a lot with AOAI and ChatGPT. So for example, we've had to produce reference architectures and basically prove out. And for us, this was at like the DoD CIO of saying, No, we might use generative AI to take this conversation, take the transcript and give it to leverage its prior learning capabilities to give us a summary. It now doesn't take our discussion, and that doesn't become part of its knowledge base moving forward. And there's ethical concerns there relative to, and again, we at Microsoft, I'm going to start probably harping on some things around ethical responsibilities. I always remember this in terms of like this little acronym, abbreviation in my head, FRP-ITA, which is, those acronyms around, fairness, privacy, inclusiveness, transparency, accountability, reliability. And it's really important when you're looking at every single one of your machine learning or AI solutions that you string together, you have to be asking those questions. Is it fair? Is it reliable? Is it accountable? Meaning if it makes a mistake, we know who to go to address the mistake and to remediate and to correct. Is it inclusive? If I have a speech to text, we're in the United States, we're a country of immigrants. Everyone comes from somewhere. It can, for example, understand, I generally speaking have what's called standard American English accent. But what do I do if I live in North Carolina. What about the accent up in the mountains, right? What about the accent in the coast? What about patois and pidgin languages? What about folks who are Creole or Cajun in Louisiana? If I create a speech to text model where it's going to assist them in some way, but it doesn't understand their accent, it's not inclusive. So take, for example, the photograph example that I used, where you're uploading the photograph. Do you lose then ownership? Does it retain your privacy? Can that photo, once it belongs to somebody else, then be used in an advertising campaign? Because it's then resold. You gave up, by participating, you gave up your likeness, and now it can be resold and maybe be used as part of a television campaign or a billboard campaign. My voice in this conversation, can my voice be then reused? And a lot of this, you're starting to see to be used for entertainment purposes, that's nice and it's all well and good, but it is a very, very short walk from entertainment to really, really potentially damaging consequences. We see an incredibly realistic television ad that is compelling me to have interest in challenges around hunger in the United States, right? I don't know if you've seen this ad on television. I'm not sure which nonprofit or government entity posts that ad. But in that example, how long before AI then could be used to create fabricated video evidence of the commission of a crime? So great care needs to be taken in terms of wielding the capability, because it can have incredibly damaging consequences. If I'm using an AI solution to help automate access to, say, Social Security benefits or other social welfare, so it could be both used in a way to potentially in a positive, I say positive, I mean what I mean in a proactive way to cause harm where it's not intended, or in a reactive way to deny access where access should be permitted. So those pillars, and those are the ones that we use at Microsoft. That comes of, we have a global office of responsible AI. I think every organization should be looking forward to it. You can maximize your efficiency and effectiveness as an organization by operationalizing AI quickly, because you'll be able to do more with the same funding and do it more effectively, do it more accurately and correctly. But at the same time, as you stand up all of this incubation of AI into the core, you also need to stand up an office around the responsible use of it in terms of how do those machine learning models, those AI solutions, how can we ensure that they're fair, reliable, accountable, inclusive, transparent, et cetera, and protect privacy. So you're going to want to do that at the same time. So that governance is going to be important.
No, I think that's good to understand, especially some of the risks that could potentially come with an AI solution. You mentioned, incorporation of it within to the business or the core of engineers, and I could see a lot of predictive things, analytics for us that could be very valuable. In particular, agent infrastructure, being able to assess, future costs or risks to agent infrastructure is one idea. But what kind of things should entities look for as they're incorporating AI, and how do we see them be able to make us more productive? I know for myself today, like I can go to ChatGPT and ask a question, and I found out that I got to tweak that question a number of times to kind of get the answer I want, and it's probably like 80% right, and I still got to tweak it. But all in all, instead of writing something from scratch that might take me a half a day, I can get a draft back in like 0.59 seconds. So it comes out really quickly, but it takes a little bit of coaxing from it. But so how can we incorporate AI more in our day to day, both for small things and also for larger things as AI develops and we get more used to it?
So I do think that, and I'll kind of weave in, this was related to some of the discussion that we've had before, is it kind of I'm going to rephrase here, Aaron, this is me being a terrible guest because I'm going to rephrase your question into a question that I like better. However, it comes back to that question of like, well, what do we do as humans, right? On is AI going to replace us? How do we work with it, right? I think what I'm doing is I'm taking your question as part of maybe this larger set of questions, and because I think that there's a broad answer. There's actually a great article that came out in August of last year, and it was written in the Harvard Business Review by one of their professors, Karim Lakhani. And the title of the article, it's actually been requoted to the point where Professor Lakhani said, hey, I just like amalgamated these ideas. I don't want credit for this. But then also it's so prolific and ubiquitous that some people, it's not even being attributed to him. But it's like that AI won't replace humans, but humans with AI will replace humans without AI. Now, this goes back to, you said, hey, I can go to ChatGPT and I can go to other generative AIs and I can ask it questions and I can get answers very quickly. But I'm learning that I need to modify how I ask it questions and how much information I get and how prescriptive I am in order to get the answer that I want, in order to get the best quality answer. So that will be completely similar to how did we all start using smartphones? How did people start incorporating the use of vehicles into their daily lives, right? How did we incorporate electricity? How did we incorporate the telephone? This is similar to all of these watershed changes in human history, and each time we had to learn how do we incorporate it. Some are obvious. It's like, okay, someone invents the washing machine, and it's pretty obvious how I incorporate that into my life, right? But that's very single purpose. But AI tends to cover so many other purposes that then it becomes the question of like, well, how do I develop skills, right, to interact with this? I think the best example that's recent in human history is really the smartphone, because we all adapted relatively quickly to touch. I'm 54 years old, but I have a 22-year-old and a 24-year-old who have had smartphones for quite some time, over a decade each, and their ability to text and emoji and so on, it's at a next level. Look, if I were willing to dedicate the time, I can become next level smartphone operator and Snapchatter that they are. I can do the Instagram grime, as my daughter called it on a recent vacation, as quickly as she can. I just have to dedicate the time to learning those skills. The same thing is true with AI. I think that there's going to be this iterative cycle, though, where we learn how to work with AI, but then at the same time, AI becomes smarter and smarter about inference, about making inferences about what we likely intend. And even to the point where when we ask the initial question, it's giving us an answer back where it may say, do you want an answer, or I want to ask you a quick question to further clarify, because I think I could give you a better answer. So I think you're going to see more interaction where it's more like maybe a trade back and forth. Right now, it's very much a shiny new toy, right? We give you an answer and it's like, oh, that's neat, but also sometimes disappointing. So I'll circle back and learn those techniques. But that's going to be important for You then related it into my job at the core. So that's where it's going to be important to start implementing different types of technical capabilities. And there's one that I would introduce to you, particularly around specialization, which is what we call retrieval augmented generation. So that's where I'm going to combine a generative AI like ChatGPT with a really, really good search tool. Now, for Microsoft, that would be like Azure Cognitive Search, where it's combing through all kinds of content that you have there at the core. And that content has been generated by you and by your engineers, by your analysts, by your specialists. It's imbued with their wisdom and experience, right? The end product. But if I take the query from a user and then I take that and send that off to a search tool, behind the scenes, what it's going to do is it's going to say to generative AI, hey, here's the question from Aaron, but also here's a search result that has pretty much what are likely to be the top 5 documents that have the answer. So we can augment the core capabilities of generative AI with very specific search results. That's when you read about, you'll hear folks in my discipline, we just walk around and probably not very inclusive, but we say, yeah, you use a RAG architecture, and you're like, well, what do you mean? It's that retrieval augmentation that's going to address like hallucinations. People are like, whoa, you mean AI can hallucinate? Yes, it can. Because in the desire to have a response, if it has little or conflicting information or not enough, its desire, its intention is to generate a response. So if it has very, very limited information, it might try and make those leaps, the deductive leaps, and generate more content than that which you're looking for, to generate conclusions beyond your desire. By doing a retrieval augmentation with, hey, this result set, we're pretty sure we have a pretty high confidence level, has the answer. And that's a well-known, search is well-known, right? Google, Bing, all these other different, there's other commercial search tools. There's Elastic Search, which is open source. All of those search tools, it's a well-known discipline. If we augment AI with that, then we'll start getting pretty good results, that are more targeted. But what that means is that the division of the engineers that focuses on, say, managing public buildings might have a different content set that is informing its retrieval augmented interaction with generative AI than your hydrologists or your water engineers. That's what I'm going to call them. I'm not a hydrologist, so please don't tell which part of North Carolina I live in. The hydrologists will come back to me for calling them water engineers.
They're probably used to it with some of the public interactions we get, and even just staff like myself, not being experts in engineering ourselves. Found it really interesting, when you talked about like adaptation of the smartphone and adopting like even automobiles. Like just think, like I remember seeing some articles published about the time that automobiles were coming out and how Americans will never, ever transition from the horse to the car because the horse has so many additional freedoms and all this stuff. And I don't know the last time that I saw a horse walking down the side of a road or anywhere else. But same with cell phones. I do not remember the last time I saw a rotary phone, or for that matter, a phone that was connected to a wall. Like it's just changed so much. And we need to kind of think of how those technologies came in and changed the world and were adapted to when we're looking at AI and how we can adapt that, and knowing that we will adapt and it will make improvements in many areas for us and for our businesses. So I think this was a great rundown and helped the understanding of how AI is. It doesn't sound like AI is going to replace our jobs anytime soon. Unfortunately, I was looking for an early retirement perhaps, but I guess I'm going to have to wait a few more years for that. But really, Evan, I just wanted to thank you for joining us today for this edition of Inside the Castle. We appreciate you and your insights. And until next time, be safe, be innovative, and be imaginative.
Thanks, Aaron. Thanks, Angela. I really appreciated the time with you today. I wish you all the best in your journey. And it is a journey for the core to kind of explore AI and how it can be implemented in all across the many and very different missions that the core has. So I really appreciated the time with you today and look forward to seeing how the Corps incorporates AI into that which you do.
Thanks for joining us for this Inside the Castle podcast. To provide your feedback, email us at cw.infrastructure.team@usace.army.mil. Stay tuned for additional Inside the Castle podcasts as we explore life inside the Corps and revolutionize civil works together.